Hello, everyone. My name is Kendall Shanklin, and I'm here to present the Oregon Tooth Journey, establishing a network of deciduous teeth collection for biochemical research. This project combines both biochemical science, pediatric dentistry, and public health to better understand how fluoride affects tooth development. Since 1945, fluoride has been added to U.S. drinking water in order to prevent cavities. While it's long been praised for its dental benefits, some concerns have raised in recent years about its potential cognitive and systemic health effects, especially in children. To explore this further, the Oregon Tooth Journey collects naturally shed primary teeth from children across Oregon. These exfoliated teeth can serve as unbiased, minimally invasive biomarkers to study the relationship between fluoride exposure and tooth strength, without the confounding factors that often affect systemic health studies. Fluoride is effective largely because it strengthens the enamel by forming fluoroapatite, a more acid-resistant version of hydroxyapatite, which is the mineral that makes up tooth enamel. In toothpaste, fluoride concentrations range from 1,000 to 1,500 parts per million, while in drinking water, the recommended level is 0.7 milligrams per liter. At these levels, fluoride works in just three main ways. It inhibits demineralization, promotes remineralization of enamel, and reduces the acid-producing oral bacteria. Fluoride systemic exposure from drinking water is minimal and is considered safe at these concentrations. Despite its dental benefits, recent studies, including one published in JAMA Pediatrics, have reported a possible link between high fluoride exposure and reduced IQ in children. Laboratory research has shown that excessive fluoride can disrupt mitochondrial function, induce oxidative stress and cell death, and interfere with neural enzyme pathways. It's important to note, however, that these effects are typically seen at much higher fluoride levels than those used in U.S. public water systems. Still, they emphasize the need for balanced biomarker-based research, which is where our project comes in. The Oregon Tooth Journey uses naturally exfoliated primary teeth to explore how fluoride exposure correlates with enamel strength and tooth development. Each tooth is paired with a demographic survey about the child's oral hygiene habits and water source. Together, these allow us to analyze fluoride's effects in a way that's unbiased and ethically sound. This is our tooth collection kit. Each collection kit includes a specimen container with a safe antiseptic solution, an anonymous demographic survey, instructions, and a tooth fairy token for the children. This approach ensures hygiene, safety, and ease of use while preserving the fun of childhood traditions. Developing a safe and effective kit came with challenges. We needed to ensure that child assent and parental consent, chosen materials were affordable and functional, and avoiding extracted teeth, which can be often damaged or diseased. In order to preserve the tooth fairy tradition, we also added that custom token so kids can still leave something under their pillow and feel a part of something special. This is our flyer that we used in order to advertise our study. To contextualize our findings, we looked at fluoridation rates across Oregon. Surprisingly, Oregon ranks among the lowest in the nation, with just 28.17% of residents receiving fluoridated water. This makes Oregon an ideal location to explore geographic variations in fluoride exposure and their effects on dental health. This slide represents the Oregon counties with fluoridated water systems. Here you can see that fluoridation status varies widely by county. For example, Multnomah County does not fluoridate its water while Washington County does. This contrast allows us to compare samples from different environments. This is the Oregon County population data. We also analyzed county population sizes and how many people actually received fluoridated water. And then this data helps us plan to where to prioritize recruitment and incorporate regional differences in enamel strength of donated teeth. So the next three diagrams represents Oregon population size based on water system data. This is specifically highlighting the population size. So the darker counties are going to have a larger population, while the less populated counties are going to be a little bit lighter in color. And so these are kind of in contrast, the size of Oregon County populations receiving fluoridated water. This is based on the number of people in the county receiving fluoridated water. So the darker colors are going to be more populated and receive fluoridated water. So for example, Washington and Marion County have the highest amount of people receiving fluoridated water. And then this map is the percentage of Oregon County populations receiving fluoridated water. So While Washington and Marion County might have the largest number of people receiving fluoridated water, Benton County has the highest percentage of people receiving fluoridated water, just due to the fact that Corvallis is such a large component of Benton County, and those people in Corvallis are receiving fluoridated water. In interviews, both dentists and researchers voiced strong support for fluoride's role in preventing cavities, but also emphasized the need for more objective research using biomarkers like primary teeth. There's also broad support for involving communities in research that directly affects their health. Because this is a human subject study, we received full IRB approval in September 2024. All surveys and specimens are de-identified, and each is labeled with a unique accession number in order to maintain anonymity while preserving data integrity. As of right now, the pilot phase is officially launched. We launched it in April of 2025 at Southwest PDX Pediatric Dentistry. Early response from families and providers has been enthusiastic, and we are waiting to receive our first specimens. Future studies. We look forward to expanding the project into more pediatric offices across Oregon, analyzing enamel strength in the lab, correlating our results with fluoride exposure and oral health behaviors, and then potentially examining these for systemic health biomarkers in future studies. The long-term vision of the Oregon Tooth Journey is to create a statewide pediatric tooth donation network in order to support ongoing dental and public health research. I would like to thank the Oregon State Honors College, Southwest PDX Pediatric Dentistry, and contributors like Emily Cowles and Hudson Jackson, who played a crucial role in developing this project. In conclusion, the Oregon Tooth Journey takes something as ordinary as a lost baby tooth and turns it into a powerful tool for discovery. By combining community participation with scientific research, we're working to build a clearer understanding of fluoride's effects and making research something that families and children can be proud to support. Thank you. Here are the citations used for this project. Thank you very much.